Hello everyone and welcome to part 2 of our winter webinar series. My name is Alison Mooney and I am a marketing executive based in Northern Ireland for Randox Food Diagnostics, specialising in honey. So our topic today, presented by Dr. Liberty Sibanda, is achieving regulatory and quality conformance in honey trade. So Randox offer the full package for honey testing. We offer antibiotic and pesticide testing on our Evidence Investigator, and we also offer quality testing on our RX Misano. So it's great that we can come together like this over shared interests in these uncertain times. Can I please ask that you refrain from using the raise your hand function during the presentation, and any questions can be asked at the end of the webinar. So without further ado, I would like to introduce my colleague, Dr. Liberty Sibanda. So Dr. Sibanda holds a PhD in pharmaceutical science, focused on the development of accelerated methods for mycotoxin detection, as well as an MBA in international business management. Dr. Sibanda has extensive experience providing solutions to government residue monitoring programs and testing laboratories in Africa, Europe, Latin, and North America. So I'm just going to pass over to you, Liberty.
Hello, and welcome. Thank you very much for connecting today and logging into our webinar. So today I'm going to take you through regulatory and quality conformance in honey trade. This is quite an important aspect, of the honey industry today because of everything that unscrupulous business practices and other things that happen to hamper trade. And so regulatory and quality conformance are quite important aspects that affect honey trade. But without much ado, I'll just give you a brief introduction to actually what honey is. Honey is defined by the European Union as the natural sweet substance produced by Apis mellifera bees from the nectar of plants or from secretions of living plants, of living part of plants, or excretions or plant-sucking insects, or the living parts of plants, which the bees collect, transform by combining with specific substances of their own, deposit, dehydrate, store, and leave in honeycombs to ripen and mature. So actually this gives a basis, for expectation of a pure honey substance. Anything other than that, will actually bring in an aspect of alteration or adulteration or lower quality, stuff like that. So so using that as a basis, you have classification of honey, the different types of honey. We have the one that we know the most, which is honey that comes from flowers. So this mainly called the blossom honey. So this is from the nectar of flowers. And then we also have honeydew honey, which comes from secretions from parts of plants. So this comes out as sap that is secreted from parts of plants. But we can further classify honey as monofloral. That means it's composed of more than 45% of one type of pollen. Okay, so that is arising from a single botanical origin. But you also have multifloral honey, also known as polyfloral honey. So that means then it actually has no predominant species that in its composition. But if we were to look at honey, the global production of honey, the composition itself is quite important, to define the origin, to define the quality. There are certain areas throughout the world that have specific types of honeys. But honey itself is made of carbohydrates mainly, more than 95%. Okay, so but the ingredients like the fructose, glucose, fructose, glucose, they have specific range or ratio, but it also depends on the source of the nectar, in which geographical origin, from which species. And sucrose makes only about 1% of dry weight of honey. Now, and then in addition, you have organic acids, there are proteins in there. Normally this is less than 0.5% and includes also the enzymes. So this is another characteristic of honey composition. So you also have minerals, you have some polyphenols, and most importantly, some vitamins as well. So in addition to that, you have aromatic compounds in honey, and these usually confer the aroma of the honey, how the honey smells. Again, if we look at the global production, there's close to 2 million tons that was produced globally in last year in 2019. If you had to look at the geographical distribution of that production, Asia, especially China, is dominating in this. Europe is the second largest. In production, Africa is coming third, and America is fourth, and Oceania, I think they have the least production. But production does not actually mirror exports, because like I said, Africa is actually third in terms of volumes of production. But if you can look here, this is now global trade. This is across continents, intercontinental trade. So now you only have Tanzania here on the African continent, but all of these actually represent the percentage of what each of these areas or each of these countries is actually exporting. Okay, and then so these are all the major regions where you have a lot of production, and you can see that in Asia, China is the largest. Okay, and then so activity, really export activity is quite important when we talk about honey, because this is a product or commodity that is of international importance. Okay, so Europe had the highest export values in the previous year, should we say, followed by Asia at 24%. And then we also have Latin America, 13.5%. And Africa had the least. But the fastest honey producing areas, you have the Ukraine, so Poland, New Zealand, Hungary. So these are up and coming honey producers and exporting areas. And they will be very, very important in the near future. So I'm not quite sure what has happened to my, okay, there we go. So now that we're talking about honey trade, it is very important now to go back to what does actually affect honey trade, because quality is the most important thing. Is we have already introduced the definition of honey, what is expected of honey, its origin, its composition. That is very, very important. It's a natural product that should not have anything added to it, that should not have deteriorated. So we are going to discuss this as we go along. Now, because honey is quite a lucrative, trading honey is quite a lucrative business. So this particular product is very prone to adulteration. Adulteration comes in various forms in honey. So there is addition of sugar, but because sugar can be detected easily, so some producers have resorted now to use some C3 carbon sources, or fructose rich agricultural products, especially like corn syrups or fructose corn syrup, some saccharose syrups, some invert sugar syrups, and these come in various forms. And these types of practices are, found all over the world. Therefore, it is very important to actually look for these anomalies in the honey. Sometimes, because the function of bees really is to break down the disaccharides or the polysaccharides into monosaccharides. So what then people do is to take sugar, the sucrose, they feed it to honey so that it is broken down then to the monosaccharides. And this is adulteration. It's another form of adulteration. And this is called artificial honey. Now, labeling is another adulteration, form of adulteration activity, where not really adulteration, but it is a falsification, especially to do with the composition or the origin of the honey, because we know that monofloras, are very, very expensive. So if you can have a monofloral honey, the price of monofloral honey is a bit high. It can fetch more money. Therefore, what you try to do then is to mix with multiflorals and still label it as monofloral, and in that way you get you can get more return on your honey. So, so identification of pure honey and its authenticity has become an important task of producers, processors, retailers and consumers, but most importantly, by regulatory authorities. This keeps happening to my presentation. Okay, there we go. So honey regulations and quality control are governed by directives, whether you're talking about what Codex says or what the USDA, FDA say, but most importantly, what we usually use as a standard is the EU regulation. It is very, very strict. So whenever we talk about regulations, we try to use the most strict of regulations, and this is the EU regulation. So to start with, you have the EU directive, which talks about the composition of honey, that you're talking about acidity, you're talking about reducing sugars. How can you actually calculate those and then come out with apparent sucrose? You're talking about HMF, which is the hydroxymethylfurfural. What are the levels of hydroxymethylfurfural? We know that hydroxymethylfurfural itself is not an adulteration or anything that is very sinister, but it is used as a quality measure of the honey. How is it been exposed to high temperatures? Because we know that the HMF is produced by the Maillard reaction and under heat conditions. And so to gauge the quality of honey and how much it has been exposed to different types of adverse conditions, therefore we can look at HMF concentrations or HMF levels. And the EU directive actually says that HMF should not be more than 40 milligrams per kilogram of honey. And the maximum actually for tropical honey, especially because tropical honey, these honeys are naturally exposed to high temperatures in the tropics. Therefore, the honey is not supposed to have more than 80 milligrams of per kilogram of HMF. So we also look at mineral content. We also look at moisture. Did they add? Did the producer add any water there just to get a little bit more volume, or did we put? Were there any insolubles that were added into the honey as well? Very, very important, because at the end of the day, whatever is added into the honey, it actually is for the benefit of the producer, whoever is selling the honey. So looking further again at the different regulations, so you have the EU regulation 1169 of 2011, which talks about what should be written on the label in terms of origin of the honey. And then again, regulation 37 of 2010 is looking at the residues in the honey. You can also talk about the codex standards. So codex really is the original standard globally, and every country really uses this as the foundation for their own standards. However, the codex standards are not they are not enforced on any country, so they are very voluntary. So every country, every business, they volunteer to actually apply these. But the voluntary nature of the codex standards means that everyone else who is outside, every honey producer who is outside the EU or the USDA, FDA jurisdictions, they have to conform to these regulations for if they need to export to these territories. So again, just to continue on regulations, Council Directive 96/23 of the European Union says that you can only export if you are listed on the third country list. Okay, so the third country list itself is a list of countries that have monitoring systems in place for residues, not only in honey, but for other agricultural products or animal products. So, but if you are to export to the EU, for example, you have to have a residue monitoring program for honey specifically. Okay, so a residue monitoring program, guarantees honey imported into the EU does not contain prohibited substances such as chloramphenicol, nitrofurans, and other veterinary drug residues or pesticides. This is just a list, an overview of countries that actually have a honey monitoring program and those that do not. So you will notice, of course, that for those that have and are honey producers, they will be very active in promoting honey trade and actually achieving, some economic growth with respect to the GDP that is contributed by honey trade. So here is some criteria from the EU directive. When we talk about blossom honey in this case, diastasis activity, which is defined as the diastasis number, should be more than 8. And of course, there are some exceptions as detailed in this column, and also gives the HMF levels, as well as the fructose plus glucose, the minimum, and the maximum sucrose content, water insolubles as well as a percentage, conductivity, electrical conductivity, and so on. So that you can actually compare to the revised codex. So in most instances, it is the same, okay, for the content, honey content, nutritional content. It is very, very similar. And you might see maybe some slight differences when you talk about honey here. But when you talk about MRALs, so no suitable methods existed before regarding, actually putting up an MRAL for any specific substance in honey. However, but there was a general approach, for MRAL definition, which was about 0.05 milligrams per kilogram for various substances that are found in honey. So, but specific guidelines for honey have now been drawn up, and if you look at Sant 11956 of 2016, and this was actually projected to be implemented in January of this year. And this was specifically for pesticide residues, like guidelines for technical guidelines for pesticide detection, and also guidelines for drug residue detection. So some of those actually included these types of pesticides here. And in terms of drug residues, your quinolones, the beta-lactams, chloramphenicol totally banned, and aminoglycosides, macrolides, your tetracyclines, your nitrofurans, but most of these actually, some of them actually are banned. And actually that came into force, being considered because at least there's been quite a lot of development in terms of analytical methods, especially LC-MSMS detection, which can go as low as possible, which is a very low detection limit. So at least affording, some labs to be able to take these at a low concentration as possible, so that consumers are not exposed to these substances. So honey quality itself can be checked, and so how can we check? Especially adulteration is one of the biggest problems. In your own home, or if you don't have a lab, you can do a quick check. There's one that they call the thumb test. You can place, you can drip some honey onto your thumb, and if the honey drips down your thumb, therefore, it is not pure. You can actually see that this honey is not pure, because honey is thick, is very viscous. It will not drip down your thumb. You can do the water test as well. You place a teaspoon of honey into a glass full of water, and you allow that honey to sink all the way down to the bottom. But if it dissolves as it goes down, it dissolves into the water, then that honey is not pure. Okay, and by the way, I'm just saying this to say, these are some of the things that people can just do. I'm just giving an example here. Okay, I'm not saying that this is the way that you should test honey. I'm just saying, you can just play around with honey this way. Okay, there is a flame test that you can also do. You dip a match into honey and strike it against the box. If the match burns, then your honey can be, you can say your honey is pure. If it doesn't burn, you might think that your honey is adulterated. You can do, again, a vinegar test, or you can do a heat test, different types. But this is all non-scientific, of course. This is totally non-scientific. Now, when we talk about scientific honey assessments, how do you test honey for quality? Okay, the origin of honey is tested using or classified using pollen. Okay, because plants have different types of pollen. So if you go to one plant, it is one type of pollen. If you go to another type of plant, in its flower, it will have another different type of pollen. So if you mix those pollen from different plants, then you have a variety of pollen in one honey sample. So that means if a bee goes to one type of plant to collect nectar, it will carry one type of pollen. If it goes to another, visit another flower again, it will carry a different type of pollen. And therefore, when you analyze that honey, you will find that that honey is composed of different types of pollen. And this is done microscopically, okay? So, so there's what you call the orienting analysis in the identification of pollen frequency. There's complete analysis identifying as far as possible all pollen grains that are there. And then you can do also an estimate analysis, involves counting 100 pollen grains of honeydew elements corresponding to 100 grams, and then making your score. So in the determination of the frequency of classes of pollen, actually is mainly used, especially to check the honeydew types of honey. So pollen is identified to species level. Okay, so therefore your honey, if it's been adulterated or mislabeled as monoflora, you can actually do pollen analysis. So this is why honey processors send their samples to a lab to do to have it checked for pollen. So when it comes to things like glucose, fructose, if so we want to check, because this is one of the frequently tested parameters in honey. So this is one of the primary indicators of sugar adulteration in honey. So one of the methods used is high performance liquid chromatography. So to set up this type of analysis, you really need some level of infrastructure in your lab to be able to run this. And of course, it comes with quite running expense. You know, the running cost of testing honey for glucose. If you send this to a lab, it will cost you 95 pounds. So, but another way to test glucose fructose is spectrophotometric. So here you can use a simple spectrophotometer to do this. You have the Fehling's test, you get the Benedict's test, you know, the different types of sugar testing for glucose or fructose. In addition to this, when it comes to adulteration, if you've adulterated your honey with different types of sugars, you know, you can actually check where these sugars are from. And this is done by the isotope ratio mass spectrometry. And it will tell you whether, you know, are those sugars from a C4 plant, what's the composition of the C4 plant in this particular honey. And because most honeys are made from nectar, which is produced by C3 plants. So when you start to see C4 plant sugars within your honey, then that is a big problem. So another test for honey quality is the diastasis activity. So this is one of the activities that actually indicate the age of honey. So how long has this honey been around? Has it been exposed also to high temperature? So so you're checking here the activity of diastasis enzymes. You know, the different types of enzymes in honey. You know, you have invertase as well. You have glucose oxidase. You've got catalase, in acid phosphatase. You know, different types, and these are all actually used by the bees to process, you know, your sugars during honey formation. So the measurement of the diastasis activity of honey has been actually put as a standard by the EU, you know, Directive 2001, 111. And this actually, when you use this, you use what is called Schade units, you know, diastasis number. And it defines Schade units should not be lower than, should be higher than 3, you know, for natural enzyme content, e.g. Citrus honey. And then it should be more than 8 for most of the honeys. So these are this is the recommended way of testing for honey. So the International Honey Commission and the European Union recommends the Fadibus test as the official honey analysis for diastasis activity. And then hydroxymethylfurfural, the Codex Alimentarius, like I've said, as well as the European Union Directive, they have specific maximum limits for that in the honey. And the International Honey Commission also recommends 3 methods for the determination of HMF. Okay, so there's the main ones really here is high performance liquid chromatography. So you can identify your HMF and quantify and actually see whether it exceeds or not. Or you can use a spectrophotometric method, you know, to check for the content of HMF. But when it comes to international trade, like I've indicated before, that it is very important, you know, to have a residue monitoring program for honey, you know, so that you'll be able to export, for example, to the EU. So the countries with the tick here, they actually have, they are actually on the 3rd country list for honey exports to the EU. For example, certain things that happened within the EU, what they call the rapid alert system, it has come up with, I mean, it lists incidences of honey, incidents of honey being either rejected or being, or some alerts regarding issues that have to do with honey. So you can see contaminants here due to, you know, veterinary residues in honey coming from different countries, from Mexico, from Ukraine, from Turkey, from New Zealand. So whether you, so these are actually for countries that are on the 3rd country list, so the export list that is permitted to export to the EU. But even those with their current residue monitoring programs, still, you still have honey that is contaminated with undesirable substances when it comes to exports. So, but how does Randox come into all this? So we have platforms actually that help in honey quality testing. So, you know, most honey producers, they collect their honey, they bring them into tanks. You can see that this lady here is doing sampling. If she sends this to the lab, it will take at least 2 weeks to get your results back, 10 working days. And it will cost per sample, you know, per analysis, close to £100. But Randox come in there, so we come in there, you can actually take your honey, do your reaction here, and then do your reading in the RX Misano. So this is our portable sort of test or machine. You can place it in your office, you can place it in your production area, you can place it in your QC lab. So it is very, very simple to operate. So on this platform, instead of taking all these samples and sending them to the lab and doing some laborious type of analysis, you can actually do a very quick test for glucose, test for diastasis, HMF, and you can actually also classify the color of your honey. And this test, this platform here is user-friendly. So all this is actually touch screen and simple sample processing procedure with a more than 97% accuracy here. And it actually allows you to efficiently process your honey in your honey facilities. So the RX Misano is a spectrophotometer, okay, and it affords you data confidentiality and fidelity, because when you analyze your honey test, which whatever analyst is involved in this, if you have more than one, whatever, you actually have to log in to the system here. You use a username and password and choose your test. You can actually modify your methods over there, choose your test, and then you choose your test over here. This is a list of tests that you have on the system, and you run whatever test you have. For results, you can go back to the file libraries here and look for results, and you can export your results with a USB. So this platform is very user friendly. It's a very small footprint and very quick. So touch screen size, it's very, very adapted to the honey producing environment. On the other hand, we have, in addition, in fact, we have the Biochip array technology, and because of the maximum residue limits and all the veterinary residue regulations, you can actually use this system to test for pesticides, to test for drug residues. And how do you do that? It's a very, very versatile type of system that we have. But on the other hand, it is suited to the honey processing, honey industry as well, because on this biochip, you can actually test a lot of parameters that are regulated, and you can detect them at lower quantities than that are specified for by the EU regulations, for example. So in a test, on a biochip, so each biochip, one of these actually contains many tests on it. And among those many tests, you have 3 reference spots. And these are mainly for quality purposes. It's an internal quality control system. And then you can generate multiple results of all the analytes that you are detecting. And these are actually detected quantitatively. And you can run 9 samples on this biochip carrier. So you can see there are 9 biochips, and you can run 9 samples. And the number of tests you can test on here can go up to 43 tests, 43 analytes really. So for example, quinolones, beta-lactams, your phenicols, your macrolides, your aminoglycosides and tetracyclines, these can be detected quantitatively because each of these actually is generated, results for each of these is generated separately, but on the same biochip. This is how effective the system is. So this is the evidence investigator. Of course, it is controlled by a computer in addition to this, but this is where the detection occurs, and you can quantitatively know whether your honey is in conformity to EU regulations, yes or no. You can also do your nitroimidazoles or chloramphenicol. If you looked at the rough rapid alert system of the EU, you would have seen that there are quite a number of chloramphenicol border rejection incidences in honey. Chloramphenicol is actually banned in foods. So, but still, for those countries that are on the list for the EU to actually export, they have national residue monitoring programs, but still, honeys are failing when they come to the EU. But using our system, you are sure that it is simple, but you are sure that you are able to detect anything that is in there before you export. And also when you are receiving honey from any source or any geographical origin, you are able to detect whatever substance that is on the regulatory list of the EU. So in this case also, the nitrofurans, you can detect all these nitrofurans in one run quantitatively. And also your sulfonamides, you can detect all these up to 15 sulfonamides in one run. And also you can do your pesticides. We have about 12 pesticides in one run for honey. So including acetamide, amitraz, you have coumaphos, imazilil, carbaryl, you have quite a lot, about 12 of them in one list that you can do. And they're all done on this system. It is very easy to do. Sample preparation is very fast, and the actual test analysis is very easy. But when you look at validations, I can just give you a small or a brief presentation here on results. To say in 2014, there was a publication after the validation of the antimicrobial biochip test by Fougere. This is ANSYS, one of the reference labs, actually the reference lab for drug residues in the EU. It is based in France. So they did this validation, and some of the results that they obtained in that validation. But you can refer to this publication, and you can look at the full validation data. What are the benefits, really? The benefits of using the biochip, and this is one of our flagship technologies in Randox. One of the benefits, really high throughput. Here you can do 45 samples within 2 hours. If you have any positives that you want to confirm, you can send this then to the lab for LC-MS testing, but at least it reduces the amount of samples that you need to send to the test, and also the cost that you incur, when you send your samples to the lab. I remember talking to one honey producer here in Europe, and they said they send, the annual cost for laboratory testing for drug residues was almost 50,000 euros. So, we showed them how much actually they can reduce that to a mere fraction annually using our system. So, here you have less false positives as well, and like I said before, it meets regulation, conforms to all regulatory MRALs. So we have quite an extensive menu of residues that we detect on this. But some of the most important things to do with our platforms is that these are very simple platforms, simple sample preparation, and we have very high specificities, very, 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 very good. When you can check this from the data when it comes to cross-reactivities and false positives, it will show you how excellent the specificities are. And the fact that we are multiplexing, our detection, it actually removes a lot of work from the end user. So if you're in a lab, instead of running 10 different methods, you just run one method. Okay, you just do one test, and it gives you quantitatively and very accurate testing. So I say very accurate as well, because we've seen a lot of data that is coming from PT proficiency testing participation of our clients, in international rounds. And I'm yet to see a failed PT. We don't generate those ourselves in most cases. We actually request data from our end users, and they are very happy, to provide that, because they are passing their PT participations, every time. Okay, so this is a very simple protocol, so where you just add your reagents, your samples to your to the biochip, you incubate, and then you wash, and then detection. So you read those, and then at the end you get your results. So why should you choose Randox? You receive local customer support everywhere in the world. Okay, we are everywhere in the world. And why? Quality, innovative products. We have been creating over the past 35 years. So we are leading in this type of innovation, and we provide higher throughput, full antibiotic profile. And now we are also actually extending our pesticide menu as well. Okay, so, and we always try, we innovate and do a lot of R&D in simplifying, sample preparation, and yet maintaining high specificities and accuracies in our results. And we provide quantitative, in most cases, really quantitative results. And at the end of the day, you will see that your running costs are much, much, much cheaper than your typical routine testing. And of course, the results, like I've said, you have very, very small amount of false positives, if at all. Okay. So I'd like to thank you all for listening right now. So I'm going to give back control to my colleague, Alison.
Thank you so much, Liberty. Okay, so I think we will look at some of the questions. Okay, so we have one, Liberty. Can you hear me okay?
Yes.
Okay, so one of the questions that came through was, can you add raw honey directly to the biochip?
How many, sorry?
Can you add raw honey directly to the biochip?
Well, in most of our methods, really, all you have to do is to dilute the honey, and you just dilute it in either wash buffer or water. Mostly is distilled water, and then you add then to the biochip.
Okay, perfect. Thank you. Another one we had in Liberty was, what are the antibiotics and pesticides standard available in US market?
Well, it's standards, yeah. Well, we can send the list. Sometimes it varies a little bit if you look at what is required, because in a lot of instances, there hasn't been a lot about there's a lot of agreement from different administrative or administrative authorities of the U.S. states and the federal government regarding the list of pesticides. Pesticides, if you look at their list, they can go up to 200 or more than 300, depending on who you are talking to. So in terms of honey, at the moment, I haven't really seen a conclusive list of pesticides that the U.S. Regulatory authorities are imposing on honey. But talking to honey traders, there's one like permethrin, for example, that these honey traders are just concerned about permethrin when it comes to exporting to America. So I guess it varies a little bit.
Thanks very much, Liberty. Just for anybody who's raising their hand, if anybody has a question, you can pop it into the Q&A box. And if we have any further questions, you can definitely contact us at info@randoxfooddiagnostics.com. Liberty, another one that was asked was, does Biochip scan all antibiotics?
Sorry?
Does Biochip scan all antibiotics?
Does it test all antibiotics?
Yeah.
Yes, all the antibiotics that are regulated in honey, you can test them on the Biochip. So we cover everything, really. So when it comes to antibiotics that are regulated, you are totally covered on the Biochip, definitely.
Great, thank you. Another question we have is, can you explain about the kits that can be used with the RX Misano?
Okay, so we can definitely send you the details of the tests. So you have the glucose fructose kit, and then you have the HMF kit. You also have the Diastasis kit. So all of them really geared to spectrophotometric analysis on the RX Misano. So, but if you want more detail on each one of them, so we can send you these by email if you don't mind.
That's great. Thanks so much, Liberty. So I think we're just going to wrap it up now, guys, because it's just a minute away from the end of the webinar. Thank you so much, Liberty. If anybody has any further questions or would like some more information, please reach out at info@randoxfooddiagnostics.com, or you can reach us via any of our social media pages. Okay, thanks so much, Liberty.
Thank you.